Example number 10. F of x equals to x squared minus 9 or x squared minus 7x plus 12. The degree of the numerator is equal to the degree of the denominator. According to the rule, if the maximum degree of the numerator is equal to the maximum degree of the denominator, then we have to cancel the leading variables. What are the leading variables here? The leading variables is x squared in numerator and x squared in denominator. This x is not the leading variable. Its power is only 1. The maximum power is 2 here, so this is gonna be the leading variable and this is gonna be the leading variable. So rule says that you just cancel these leading variables. When I cancelled x squared, I left only with a 1. There is 1 in front of x squared. And when I cancel this x squared, I will leave only with a 1 here. So I will have 1 over 1. Therefore my horizontal asymptote will be 1. Because this x squared will cancel with the x squared, and their respective coefficient will be 1 over 1. 1 over 1 equals to 1. This is going to be my horizontal asymptote. Well, let me show you an xy plane here. Exactly on y equals to 1, I have this horizontal asymptote. This dotted red line is the horizontal asymptote. Remember, horizontal asymptote crosses y-axis, not x-axis. Vertical asymptote crosses x-axis. So at y equals to 1, exactly on y equals to 1, I have this dotted red line, which is the horizontal asymptote. When you look to the given function, can I do factorization here? Yes, I can do factorization. When I do factorization, I will have x plus 3 into x minus 3 or x minus 4 into x minus 3. Just factorize the numerator and denominator. These are the two factors for the numerator, which is x squared minus 9. And these are the two factors for the denominator. What about to cancel the common factors? Do I have common factors here? Yes. I have x minus 3 in the numerator and x minus 3 in the denominator. So x minus 3 is common here. Just cancel x minus 3 with the x minus 3. When I cancel x minus 3 with the x minus 3, I will left only with x plus 3 or x minus 4. This is going to be the remaining equation. Now to set the denominator equals to 0. What is my denominator right now? X minus 4 is the denominator now. Because I have cancelled this x minus 3 with this x minus 3 in the numerator. So I left only with x minus 4. X minus 4 is the only denominator that I left. So just make it equals to 0. Set x minus 4 equals to 0, which implies that x equals to positive 4. Just rearrange this equation. This negative 4 will go on the other side to become positive 4. Therefore, I have x equals to 4. So this x equals to 4, this 4 is my vertical asymptote. Exactly on x equals to 4, I have this dotted line, which is my vertical asymptote. So I can write that vertical asymptote is at 4. 4 is my vertical asymptote. Now to set the cancelled factor equals to 0. X minus 3 is the cancelled factor. So just set x minus 3 equals to 0. When you rearrange the equation, you will get x equals to positive 3. So exactly on x equals to 3, there is a hole. This is going to be the hole at x equals to 3. So I can write that hole is at 3. How to determine the coordinate point? My x value is 3, but what about the y value? You have to put x equals to 3 here. So 3 plus 3 equals to 6. And 3 minus 4 is negative 1. So plus 6 or negative 1 will be negative 6. Negative 6 will be the y point. So I have 3 comma negative 6. Exactly on x equals to 3. 1, 2, 3. And negative 6 along y-axis. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. 3 comma negative 6. This is the location of the hole. I repeat it, x value is 3. To find the value of the y, you have to put 3 in this equation. 3 plus 3 is 6, and 3 minus 4 is negative 1, which equals to negative 6. Negative 6. Negative 6 is the point along y-axis. Here is the hole. Example number 11. F of x equals to 4x squared minus 72 or 2x squared minus 8x minus 24. Identify the degree of the numerator with the degree of the denominator. Look, the leading variable is x squared in the numerator and the leading variable is x squared in the denominator. The degree of the numerator equals to the degree of the denominator. If the degree of the numerator equals to the degree of the denominator, you have to cancel the leading variables. Just cancel x squared with the x squared, and their respective coefficient will be the horizontal asymptote. Its respective coefficient is 4 and here is 2. 4 over 2 equals to 2. So 2 is my horizontal asymptote. Let me draw you in xy plane. Exactly on y equals to 2, there is my horizontal asymptote. If I draw a rough graph, maybe when you come from this direction, the graph will divert on the right side in positive direction. From this direction, it may go on the left side in negative direction. I repeat it again, this is the rough sketch. This is not the perfect graph. All the examples from example number 1 till now, these all are the rough graph that I'm doing. So I can simply write that my horizontal asymptote equals to 4 over 2 equals to 2. Leading variables are cancelled and their respective coefficients are 4 and 2. 4 divided by 2 equals to 2. 2 is my horizontal asymptote at y equals to 2. This dotted line is my horizontal asymptote. Look to the function. Can I do factorization here? Yes, I can do factorization. Just do factorization here, which equals to x minus 6 into x plus 6 or x minus 6 into x plus 2. How I did it? When you take 4 common, you will left only with x squared minus 36. And then when you take 2 common, you will left only with x squared minus 4x minus 12. And then when you divide 4 by 2, you will left only with 2 here. So x squared minus 36 equals to x minus 6 into x plus 6. And x squared minus 4x minus 12 equals to x minus 6 into x plus 2. These are the two factors for the numerator, and these are the two factors for the denominator. That's what we did factorization here. But what about to cancel the common factors? Is there something common to cancel? Yes. I have x minus 6 in the numerator and x minus 6 in the denominator. X minus 6 is common. Just cancel x minus 6 with the x minus 6. You will left only with x plus 6 or x plus 2. After cancelling the common factor, I left only with x plus 6 or x plus 2. I have no more x minus 6. Now to set the denominator equals to 0. My final denominator is x plus 2. I don't have x minus 6 because I have cancelled it. So I left only with x plus 2 in the denominator. Just set x plus 2 equals to 0. When you set x plus 2 equals to 0, after rearranging you will get x equals to negative 2. This negative 2 is my vertical asymptote. Exactly on x equals to negative 2, this is going to be my vertical asymptote. So I can write that my vertical asymptote is negative 2. But what about the whole? For the whole, you have to set the cancelled factor. The cancelled factor is x minus 6. Just set x minus 6 equals to 0. After rearranging, you will get x equals to positive 6. So exactly on x equals to 6, there is a whole. So I can write that whole is at 6. At x equals to positive 6, positive 1, positive 2, positive 3, positive 4, positive 5, positive 6. There is a whole. But how to determine the coordinate point? Look, my x value is 6. To find the value of the y, I have to put x equals to 6 in this equation. So 6 plus 6 is 12. And 6 plus 2 is 8. 12 divided by 8 is 1/2. So my y value is 1 over 2, or 0.5. 0.5 is here. So my coordinate point will be 6, 1 over 2. 6 is along x-axis, 1, 2, 3, 4, 5, 6. And 1/2 is 0.5 along y-axis. This is going to be my 1/2. So from this given equation, I got all the three values. For the horizontal asymptote, I have 2. Exactly on y equals to 2, I have this dotted red line, which has been drawn horizontally. This is my horizontal asymptote. and at x equals to -2, this is my vertical asymptote, and at x equals to 6, there is a hole is at x equals to 6 at this point.